Hello everyone, welcome to the AI Club. My name is Uddesh Soman, and today we are going to have a look at RNN example. Previously, we have seen RNN examples for numerical sequences. In this session, we'll see RNN example for predicting the next word of a sentence, or using RNN on the actual words to predict next word or the next sentence. So for this session, we'll only have a look at uh, predicting the next word of a sentence. So here we just import our all the required libraries. The main ones here highlight LS, simple RNN, which we are going to use in this example. So let's move on. We import our data set. The data set is available as a text file. So I've stored it in my drive. I'll provide it with the code file. Code file. So we create a new data frame. We name the columns word one, word two, word three, and then using pandas read CSV, we read this text, and the delimiter here we have to provide is /t, because in our text file the words are separated by tabs. So each tab represents a separate word or separate entry. So we separate our data using tabs. So we provide here delimiter is equals to \t, the name of columns, the ones we have declared earlier. We print the shape of data, so we can see we have 5,351 samples and 3 words in each sample. If we take a sample or few examples, we get these. So in this problem, what we are going to do is we'll train our model on word one and word two, and using these 2 words, we'll predict the next word, that is the word three. So the word three will be our target attribute, and word one and word two are going to be our input attributes. We just to check on frequency of these words. So for the word one, we have these words: love, loved, hate, hated, loves, lovely, loving, hates. And frequency of second word. So there are too many words and their frequencies are provided. We can just use values count to predict. Now, the important thing we require is unique words in the third column. So for that, we just take column values, and then for each column, we take this. We call each value and it append it into unique words. This unique words is a list. We append each and every word of our data set into unique words. And once we have our unique words, we call NP unique. So NP unique will delete all the duplicates, and we'll have a set of pure unique words. So this set here, you can see these are all the unique words that are available in our text file. Now we count all the unique words. So the count of unique words we'll just call length of the list. So we have total 139 unique words. Now, why do we need that? Because LS any machine learning model by default cannot understand words as data. So we'll convert those words into numbers for training. What we'll do, we'll take those words, we'll convert those words into numbers. Now, each number represents a token. So we can say that here, if we have 1, then A is equals to 1. So we can provide A is equals to 1. So in our model will calculate for 1, whatever calculation it makes or whatever training it makes, it will make for 1. And 1 would represent A. Then 2 for able, 3 for about. So this is kind of token generation. We are creating numerical tokens for each word. So for that, we create a dictionary, word indices. So word and the words are the key, and the values In dictionaries, we have key value pairs. So key is word and value is index of that word. So we enumerate unique words. Enumerate actually returns the entity as well as its index. So we create a dictionary of word and its index, and then because once we make prediction, we'll receive an index. We have to predict word using that index. So index to words, a dictionary for reverse operation. So just switch the position of I and W. So it becomes that indices becomes the keys, and W or the words becomes the values. We the call remains same, enumerate unique words. Then we one hot encode the words. We can using one hot encoding we can predict for multiple classes, or the default classification of that Keras sequential is one hot encoded vector. So we can one hot encode. We can also the as far as this prediction is concerned of the input set, we can either one hot encode it or not. That depends on us. That would only create multiple number of input attributes. So in case we have word one and we one hot encode it, so that would mean as many number of unique words we have in word one, that many number of columns will generate. So we take this we categorical using Keras utils, two categorical. We convert into one hot encoded array. Once we have the one hot encoded array of all three words, word one, word two, and word three, we can start with prediction. So word one, word two, because we need separate input attributes. So we take word one and word two from this, and we create a separate data set of word one and word two. This one is not one hot encoded so far, right? We are taking it directly from in our original data set. We have created one hot encoded vectors as well. We'll see their use. So here we are just taking word one and word two, all the columns from this. We uh, enumerate those lists. So whatever the column values, whatever the values in those columns, word one and word two, we take those values and create a sort of list out of it. So this all we are doing because we want to make it into a sequence. We are converting it into a sequence. Once we have the sequence, we convert it into an array, because by default it does not take list, it takes arrays or data frames as input. So we are converting into numpy array, and this numpy array will reshape it. So we reshape word one, word two, and how we reshape it with the shape zero. Shape zero will return us number of samples. Since we have sequence of two words, we have a sequence of two entries, right? Word one, word two, and there is only a single sequence. We are not training it on multiple sequences or multiple features. So one hot encoding, if we want, we can do. If we do not want, as far as input is considered, one hot encoding is not required necessarily. We can, it's optional. We can do it or not. That depends on us. We check the shape. So here we have one hot encoded vector, and then we print time steps. So time step is number of entries in a single sequence. Then input nodes we can, for the machine learning model, we can design our input ourselves, as many input number of input nodes we want to give, and output nodes. So output nodes will be 130, and because previously in the number sequence problem, we have seen regression type examples. This one is a classification type. So since it is a multi-class classification, so as many outputs we are taking output nodes as that same. Now we declare a RNN model, sequential, simple RNN. Simple RNN we have also seen simple RNN. So here we are just using simple RNN. We can use LSTM. We have already seen the use of LSTM. Everything would remain same. Input shape. So we provide our input shape, number of words in each sequence, and the number of features or number of parallel sequences. That is here. And then for the dense layer, output. So word 3 1 hot encoded and its shape. Shape 1 would return 139. So since we have 139 words, so 1 hot encoded array of word 3 means all the unique words. Activation softmax, since it is a multi-class problem, we check our models. We only have a single layer of simple RNN and a single dense layer. We train our model, we fit it, compile it. For compilation, it is a multi-class problem. So categorical cross entropy, optimizer Adam, matrices, accuracy. We fit our model, and the result of fitting we have here. So this is a function we are going to use. This function will take in our text. It will take our text, convert our text into a sequence, and that sequence will be used for prediction. And whatever the prediction will receive, will print it. So in text, so here we are providing list, the word 1 and word 2, and the word 3 should be the output. So input encoded. So word indices of I for I in X test in text. So 0 and 1, because we only have 2 words. So 0. So first it will take love, then in the second iteration it will generate these two words as a sequence. They are encoded. They are converted into array and reshaped. This word underscore indices would take index of that particular index from text. So word indexes would actually return the indices. Remember, we were using numerical data. We cannot train it on word data, right? We have to train it on some numerical data. We have generated tokens. So this will return that sequence of tokens. So love it. So let's say love has a token number 5 and it has token number 10. So we'll receive 5, 10. That will be our sequence. And then next entry will be the next item would be output. We predict using the predict command, and then classes, because since the output would be 1 hot encoded vector, the output would also be the 1 hot encoded vector, and we need a single class as output. So for that, we'll use that np argmax. It will take the predicted value axis is equals to 1, because we need to create a single entry. So axis is equals to 1. Single entry, that single entry would be the answer of 1 hot encoded. In case 1 is in, let's say, output is 4, so we'll receive every entry, every column, the value remains 0. For 4 it is 1. So that will receive, and np argmax will actually give us classes is equals to 1. And using that, we have our reverse index to word dictionary. In that, we call our classes as x is equals to 0. So we call our prediction. Our prediction, let's say it was 4. It could be any number. Let's say it was 4. So whatever our prediction be, that token, that our prediction is actually token to this dictionary. So we provide that word token and the corresponding word is printed. So we call that function for love it. So it becomes love it input and output is when. So we are predicting the next word. This would be an example of many to one kind of problem. We have many inputs, two inputs here, and then we are making the next word. So many to one. I've tried another example with many to many, a whole paragraph, predicting it for paragraph, but since the data was insufficient, the results were not good. Okay, so that was the end. Thank you very much. If you guys have any problems, please ask.
Thanks so much. So floor is open for questions and anyway, so next class will be now advanced topics. I have been promising that a lot of fundamental concepts which are covered in CNN, RNN and LSTM and ANN. So these topics, there are many abstract concepts which are given, and I don't think we covered it in great detail while in our lectures. So I kept a separate section on advanced topics to cover those sections. So this week, I think we have already covered RNN and someone explained very nicely the coding part of it. So I think RNN is fully closed now. And we'll give one assignment to you this week. And from next week, we'll have 2 or 3 classes on advanced concepts, which you have heard a lot about it. But many of these may not be clear to you as beginners because we hear it, we use it, but things are not that clear. So in the next 2 to 3 classes, we'll try to cover that in detail. And then after that, only coding part will be in transfer learning. I think that is fairly easy compared to what we have already covered. So thanks once again so much. So with this, I close today's session. And if there are any questions, I think we can take it up.